Have you ever noticed how confidently you talk about space without ever touching it? You say outer space like it's just emptiness, like it's nothing. But what if that's the biggest mistake your brain makes about the universe? What if space is not a backdrop at all? What if it's a real participant, something that can stretch, tense, ripple, store energy, and distort what you call reality? Because can space stretch sounds like a childish question until you realize Einstein's entire revolution begins with a more disturbing version of it. If space is just an empty container, why does the universe behave as if the container has properties? Why does gravity act as if the stage itself is bending under the actors? And why do those bends change the way time passes? Most people imagined gravity as an invisible pull, like a rope, like a hand reaching across distance. That's comforting, that's intuitive, and it's wrong. Einstein didn't upgrade Newton, replaced the picture. Entirely, he said, stop imagining a force. Imagine geometry. Imagine that mass and energy don't pull on objects. They reshape the arena those objects move through. Space and time are not passive. They respond. Here's the unsettling part. You already live inside this response. Right now, your body is not simply sitting in space like furniture in a room. You are embedded in something that behaves more like a fabric than a void, except it's not fabric and it's not a metaphor you can hold in your hand. It's a structure, a set of rules so strict that even light itself has to obey them. And that's where the real tension begins. Because once you accept the possibility that space has structure, the question becomes sharper. What does it even mean for it to stretch? Stretch compared to what ruler? Measured against what fixed background? If the background is the thing changing. This is exactly the trap Einstein walked you into. You want a stable reference point, but relativity destroys the idea that the universe owes you one. So when cosmologists say the universe is expanding, your mind immediately pictures galaxies flying outward into empty nothingness, like an explosion, like debris. But that picture smuggles in a secret assumption that there's a fixed space outside, waiting. Einstein's discovery makes that assumption feel childish, because expansion can mean something far stranger, not matter moving through space, but space itself increasing between matter. If that sounds like word games. Good. It should. That discomfort is the first sign you're about to see the universe the way Einstein did. And in the next step, we're going to hit the exact pressure point that forces space to become stretchable, not as but as a consequence of one brutal fact about reality that refuses to negotiate the speed of light. Before we push this idea further, pause for a second and notice what just happened in your mind. Something you thought was simple space as an empty stage has already started to feel unstable. That discomfort is not confusion. It's understanding beginning to form. And this only works if you actively process it, not if you let it wash over you like background noise. If this idea about space being a physical fabric is already bending the way you think about reality, let me know in the comments. Don't just type cool video. Say what felt wrong. Say what surprised you. Try something simple like space is not empty, or the stage is alive. Writing it down forces your brain to lock the concept in place. And if this kind of content matters to you, content that doesn't just give facts, but actually rewires intuition, hit the like button. It tells the algorithm this is worth spreading, but more importantly, it tells you that you're choosing understanding over comfort. Subscribe if you want to keep going deeper, because everything that comes next builds directly on this idea. Nothing here is random. Now that we've cracked the illusion that space is passive, we're ready to touch the real pressure point. One discovery that forces space to stretch, whether you like it or not. And that discovery doesn't start with gravity. It starts with light. You could talk about space stretching all day, but it still feels optional, like a philosophical metaphor you can ignore. Einstein's move was crueler than that. He found a single fact about the universe that doesn't care what you believe. And once you accept it, space can't stay rigid. Time can't stay universal. The old picture collapses. That fact is simple enough to say in one breath, Everyone measures the speed of light to be the same. Not almost the same. Not the same if you correct for something. The same. Always. And if your brain is healthy, that should immediately feel illegal. Because in normal life, if you're on a train and you throw a ball forward, the ball goes faster relative to the ground. That's how motion works in your instincts. So, if you chase a beam of light and shine a flashlight forward, common sense screams, the light should go faster relative to the ground, because you're already moving. But nature refuses. You can move toward it, away from it, chase it with a rocket light, still clocks in at the exact same speed when you measure it. Now, here's the first twist. The universe doesn't to solve this by adjusting light. It solves it by adjusting you. It quietly changes the bookkeeping of reality so the numbers work out, and that bookkeeping is what you call time and distance. If the speed of light is fixed, then the only way different observers can all agree on that fixed speed is if their measurements of time and space are allowed to flex. Your seconds and my seconds don't have to match. Your meters and my meters don't have to match. What has to match is the one thing that seems like it shouldn't. The speed of light. That's the moment Einstein stops being a smart guy with equations and becomes a threat to intuition. Because it means the universe has a deeper loyalty than your everyday experience. Reality would rather bend time than let light break its rule. And here's the second twist, the one people miss. This isn't a weird property of light. The constant speed is a clue about the structure underneath everything. It's like discovering that every map, no matter who draws it, has the same north. You don't argue with IDEO. Redesign the coordinate system. Einstein realized space and time aren't separate containers, they're welded into one geometry, and the speed of light is basically the conversion rate between them. So when you ask, can space stretch? You're really asking, can the universe change its ruler? And the answer is, it already did. The moment light refuses to add speeds, the ruler becomes flexible by necessity. And once that door is open, gravity will walk through it and do something even more disturbing, because motion isn't the only thing that can make the ruler bend. Before we go there, I want you to lock in the key idea. Light doesn't adapt to space-time. Space-time adapts to keep light consistent. If that sentence feels like an insult to common sense, good. Once you accept that time can slow down, something quietly breaks in your mental model of the universe. You may not notice it immediately, but the damage is already done. Because time and space were never supposed to behave differently. In your intuition, time is flexible in a poetic way. You feel it drag. When you're bored and vanish when you're happy, but space feels solid, fixed, measurable. A ruler is a ruler. Einstein noticed the inconsistency. If time can dilate because of motion, why would distance remain immune? Why would the universe treat seconds as negotiable but meters as sacred? That would be an odd design choice. Nature is rarely that ace. Here's where relativity becomes genuinely unsettling. Length is not an intrinsic property of an object. It's a relationship between the object and the observer measuring it. The faster you move relative to something, the more its length along your direction of motion shrinks. Not visually, not as an illusion. Physically, the space itself compresses in the direction you're moving. Your brain hates this idea because it destroys the notion of a universal ruler. You imagine a metal bar floating in space. Surely everyone agrees on its length. But relativity says, no. Two observers moving differently can both measure that same bar and get different answers. Neither is wrong. The universe does not privilege one measurement over the other. Now pause and feel how dangerous that is. If length depends on motion, then space is no longer a passive arena. It's part of the measurement. It participates just like chimie. And once both time and space lose their absoluteness, the idea of a rigid cosmic grid collapses completely. Here's a subtle twist. Most explanations skip. Nothing feels different to the person moving. Ruler doesn't warp in their hands. Their body doesn't feel squashed. Their clock ticks normally. Reality only reveals its flexibility when you compare different perspectives. That means the universe is quietly inconsistent in a way you can't locally detect. There is no internal alarm that goes off saying space is stretching right now. This leads to an uncomfortable realization. The universe does not come with a built-in reference frame. There is no master viewpoint where space and time are really correct. Every observer carries their own version of reality, stitched together by the same physical laws, but sliced differently through space. At this point, many people try to retreat. They say, fine, this is just about motion. Extreme speeds. Weird edge cases. But Einstein didn't stop there. He asked a more dangerous question. If motion can bend time and space, what else can? And the answer he found was devastating to the old picture, because motion isn't the only thing that distorts spacetime mass doisto. And when mass enters the story, space doesn't just contract or stretch along a direction, it curves. And once space can curve, gravity stops being a force altogether and becomes something far stranger. This is where the story stops being uncomfortable and starts being genuinely Up to now, you could still imagine relativity as a correction layered on top of the old universe. Time stretches a bit. Space contracts a bit. Strange, but manageable. Einstein didn't accept that compromise. He realized something much more radical was hiding underneath. Ask yourself a simple question. When an apple falls, what is it actually responding to? The Newtonian answer is automatic gravity pulls it downward. An invisible force reaches out, grabs the apple, and drags it toward Earth. It feels intuitive because you grew up pushing and pulling objects. But intuition is not evidence. Einstein asked what gravity would look like if there were no force at all. And shockingly, the universe allowed that interpretation. Instead of being pulled, the apple is simply following the straightest possible path in a space that is no longer straight. Mass doesn't tug on objects. Mass changes the geometry they move through. This is the moment space stops being a container and becomes an actor. The presence of mass and energy tells space-time how to curve, and that curvature tells matter how to move. Nothing is reaching across distance. Nothing is pulling. Objects are obeying geometry the way a train obeys tracks. The word fabric suddenly stops being poetic and starts being precise. Not fabric like cloth, but fabric like structure. A set of relationships that can stretch, compress, and curve. Time slows down near mass. Space distorts around it. And what you experience as gravity is just your attempt to move straight through a curved reality. Here's the twist that most people miss. Gravity doesn't just bend space, it bends time more strongly. Clocks closer to massive objects tick more slowly than clocks farther away. This isn't theory, it's measured. If you put one clock on the ground and another on a satellite, they disagree. The universe itself refuses to synchronize them. And now, something strange clicks into place. Earlier, light forced space-time to flex to keep its speed constant. Now mass forces space-time to curve to keep motion consistent. Two completely different phenomena, light and gravity, both point to the same conclusion. Space-time is not passive. It reacts. This redefinition quietly erases the idea of a fixed cosmic backdrop. There is no empty stage underneath reality. The stage is reality. It stretches with expansion, warps near mass, and ticks differently depending on where you are and how you move. And once you see that, the question, can space stretch, feels almost naive. Stretching is the mildest thing it can do. At this point, space is no longer something you can picture as a static grid. It bends near mass. It stretches with motion. But there's one last assumption quietly hiding in the background, that space itself, as a whole, stays the same size. Einstein shattered that too, though not intentionally at first. When astronomers say the universe is expanding, your brain immediately builds the wrong movie. You imagine galaxies exploding outward into an empty void, like shrapnel flying away from a blast. That image feels natural because it preserves a familiar idea, a fixed space that things move through. But relativity doesn't allow that comfort. In Einstein's framework, it's not that galaxies are racing through space. It's that the space between them is increasing. The ruler itself is changing length. Every second, the distance between faraway galaxies grows, not because they're traveling, but because the geometry connecting them is stretching. Here's the unsettling twist. Nothing needs to be pushing space outward. Expansion isn't motion in the usual sense. It's not driven by force or velocity. It's a change in scale, a redefinition of distance that happens everywhere at once. This is why expansion doesn't violate the speed of light. You'll often hear that distant galaxies are moving away from us faster than light. That sounds like a paradox until you realize they aren't moving through space faster than light. Space itself is expanding. And relativity places no speed limit on that. Light's rule applies to motion inside spacetime, not to spacetime changing its own geometry. Now pause and feel how far this has gone. Space can curve. Space can stretch. Space can grow. The thing you thought was the most stable part of reality turns out to be dynamic on the largest possible scale. The universe isn't just in space. The universe is space evolving. This reframes everything about cosmology. There is no center of the universe. There is no edge. It's expanding into every point sees every other distant point moving away. Expansion isn't happening somewhere else. It's happening right here, too. The effect is tiny, locally, drowned out by gravity, but it never turns off. And this raises a deeply uncomfortable question. If space itself stretches over time, what happens to light traveling through it? What happens to energy? What happens to the meaning of distance and age when the ruler keeps changing while the measurement is still in progress? That question leads directly into one of the strangest consequences of Einstein's Universe 1 that reveals how deeply space, light, and time are entangled in ways your intuition was never designed to handle. Once you accept that space itself can grow, something subtle but deeply disturbing follows. Light is no longer just traveling. It's being carried by a ruler that won't stop changing while the journey is still happening. And that breaks another comforting intuition. That energy is always conserved in the simple way you expect. Imagine a beam of light leaving a distant galaxy billions of years ago. When it starts its journey, space is smaller. While it's traveling, the universe keeps expanding. By the time that light reaches your telescope, the space it moved through is larger than it was when the light was emitted. The result is not optional. The wavelength of the light gets stretched along with space itself. This is what redshift really is. Not Doppler motion in the everyday sense, not galaxies running away, but light being stretched because the fabric it rides on is stretching. The photon doesn't lose energy because it collided with something. It loses energy because the geometry changed underneath it. That sentence should make you uneasy. Where did the energy go? In everyday physics, energy is sacred. It moves around, transforms, but it doesn't just fade. Yet in an expanding universe, energy conservation becomes local, not global. Energy is conserved in small regions of spacetime, but the universe as a whole doesn't promise to keep a global balance sheet. There is no cosmic accountant making sure nothing is lost when space stretches. This is one of the quiet shocks of general relativity. The rules you learned in ordinary mechanics don't scale cleanly to the universe itself. When spacetime changes, energy doesn't behave the way your instincts demand. Light gets redder. Radiation cools. The universe slowly drains intensity simply by growing. And now notice the deeper implication. If light stretches, then information stretches. Signals from the early universe arrive diluted, slowed, weakened. There are regions so far away that their light will never reach us. Not because it isn't fast enough, but because space expands faster than the signal can cross it. The universe literally outruns its own messages. This creates horizons limits, not of technology, but of geometry. There are events that exist, that happen, that are real, but are forever unreachable from here. Not hidden behind walls, not blocked by matter, just separated by stretching space-time. At this point, the idea of a single, shared cosmic now completely collapses. Different regions of the universe are not just far apart in space. They are effectively cut off in time. Expansion doesn't just separate objects. It separates realities. And this brings us to a final, deeply human problem. If space stretches, if chi bends, if light ages differently depending on the path it takes, then what exactly is the reality you think you're experiencing right now? Is it the universe as it is the universe as it was able to reach you? By now, the damage to your old worldview is complete. Space isn't fixed. Time doesn't flow the same everywhere. Light ages as it travels, energy quietly thins out as the universe grows. And once all of that is on the table, a final question becomes unavoidable, one Einstein himself was deeply uneasy about. What does now even mean? When you look at the night sky, you are not seeing a snapshot of the universe. You're seeing a patchwork of different times stitched together by stretched light. Some stars appear as they were thousands of years ago. Some galaxies appear as they were millions or billions of years ago. There is no single cosmic present being revealed to you. Reality arrives delayed, distorted, and incomplete. Relativity makes this worse. Two observers moving differently will disagree on which distant events are happening right now. And neither is wrong. The universe does not come with a universal clock that labels moments as present. Now is local, personal, a slice through space-time chosen by motion, not by authority. This is where Einstein's universe becomes existentially uncomfortable. If the present is not universal, then reality is not something that simply is. It's something that depends on how you move through space. The universe is more like a four-dimensional block of events than a movie playing frame by frame. Past, present, and future all coexist in the structure even. If your brain can only experience one slice, your intuition rebels here because your identity is tied to the feeling of becoming. You feel like you're moving forward through time. But physics offers a colder interpretation. You are not moving through time so much as occupying a particular trajectory through space. The sensation of flow comes from memory, entropy, and biology, not from the universe pushing you along. And here's the final twist. Expansion doesn't just stretch space. It stretches, meaning there are parts of the universe that are real, but forever inaccessible. There are futures that exist in the equations, but will never influence you. Reality, in Einstein's universe, is bigger than what can ever be observed. So when you ask, can space stretch, you're really asking something much more dangerous. Is reality fixed, or is it relational? And Einstein's answer, whether he liked it or not, points toward a universe where what exists is inseparable from how it's measured, where the stage and the actors are the same thing, evolving together. If you made it this far, you didn't just watch a video, you wrestled with an idea most people instinctively avoid. You let go of the comfort of a fixed space, a universal now, and a reality that behaves the way your intuition demands. That already puts you in a very small group. If this perspective genuinely shifted how you think, do 3 simple things. First, subscribe to the channel. This channel is for people who want to understand reality, not just hear facts. What comes next builds directly on what you just absorbed. Second, leave a like not for the algorithm alone, but as a signal to yourself that this kind of deep, uncomfortable thinking matters to you. And finally, leave a comment. Don't just say great video. Write something specific so your brain locks it in. Try commenting, nitrogen monoxide, universal now, or space is not empty. Those words matter more than you think. And when you're ready to go even deeper, Click the next video on the screen. It takes this idea one step further into a place where intuition almost completely fails, and Einstein's universe becomes even stranger. I'll see you there.